All right. So this is going to be the release live stream for LXD 5.7. I'm Stefan Greber, project leader for LXD at Canonical. This live stream is going to be slightly different because, well, I'm streaming this from my laptop in a new house that's I just moved into, and there's still a lot to do. There's probably going to be quite a bit of echo, and it's possible the stream will also be lower quality or be cutting kind of on and out. Hopefully, not really losing any frames or anything, and we can still do the demo for this this release. But if there's anything weird, let me know in the chat. I'll try to keep an eye on that. But yeah, hoping for the best. All right. So LXD 5.7. It's a pretty good release. It's got a few nice improvements, one of which I was really looking forward to, and quite a lot of bug fixes. So let's go through that. So the first thing, and kind of the headlight for feature for this release is Let's Encrypt support. So it's technically ACME, ACME, whatever it's pronounced, support in LXD. For most people, that means Let's Encrypt. What that means on the LXD side is you are now able to configure a domain in LXD, such that you agree to terms of use of the provider you're using, and set your email address if you want to get notifications. And once you've done that, LXD will go and reach out to Let's Encrypt automatically for you, and will issue a certificate. So I've got a server that I've routed a public address to, and hopefully in the demo we can make it work. I'm saying hopefully because this is like I literally put the DNS record for it up a few minutes ago. I'm hoping it will propagate by the time we actually get to it. Let's see. Next thing is Cloud-init validation. So LXD have supported Cloud-init for a long time, initially through those user.config keys. We had user data, user vendor data, and user network config. And it was just being accessed by Cloud-init to configure itself. It was not really official LXD support in any way, but it was working. Then a few releases ago, we introduced the Cloud-init config namespace. So cloud-init.networkconfig.userdata.vendor-data. And this is now, the goal of those was to be a bit more formal about LXD actually supporting this, and to also allow for us to do validation down the line. So initial validation is present now in LXD 5.7. It's currently quite limited. We effectively check whether the config is supposed to be YAML, and if it's supposed to be YAML, whether the YAML passes at all. That's pretty good because 99% of times when someone has an issue with Cloud-init and LXD, it's because of broken indentation in the YAML or something along those lines. With that validation, it will get picked up. You can go fix your indentation, save it again, and that should work through. It's not perfect because ideally we would like to actually validate the net plan or Cloud-init configuration itself. And it's something we can add pretty easily once they are well supported, well tested, JSON schemas available for both of those. Then we can do automated validation of those config keys, and that is make sure that all the types are correct and those kind of things. So looking forward to expanding that, but the initial support we've got in LXD 5.7 should already catch well over 90% of the issues we've seen so far. Then the next thing we've added are a number of internal metrics to the metrics API. So far, the metrics API has only supported resource usage. So you were able to see instance, disk, CPU, memory, network, all that kind of stuff through that API. But there was not much about how LXD itself was doing. That's changing now with a bunch of new metrics being exposed. All of the LXD_Go_something config metrics are kind of internal metrics coming from Go that we're exposing. So that includes a lot of memory management entries, some of the details on the garbage collection, number of Go routines that are being run. And yeah, that's pretty much it for the Go side. Then LXD itself exposes the total number of background operations that are running, as well as how long the daemon's been running. So that should be helping quite a bit to track kind of production servers, see if there's anything weird going on. And that kind of data over time is going to be extremely useful should you file a LXD bug, especially around performance or memory leakage. This will be very, very useful. Then we've got cluster join token expiry. So that adds support for, or exactly what it says, being able to set an expiry on a cluster join token, which up until now did not have any. That's not ideal because an unused join token has a lot of privilege against LXD. And with this feature, now we can make sure that after an hour or a day or whatever you like, the token becomes no longer valid, and that avoids potential issues with unused tokens. Technically, LXD did expire those tokens, but that was only when LXD itself would restart, which is not really a predetermined time. So this is quite a bit better. And lastly, we've added proxy device hot plugging to virtual machines, which is quite limited in the case of VMs because unlike containers where a lot of features are supported around proxy devices, for virtual machines, it's limited to just NAT. And that's also why the hot plug was so easy to implement in this case, because it's just an NAT rule on the host. So this is now allowed. All right, let's try and do a demo on a few of those. One thing I guess, since the first one is Let's Encrypt, might be worth mentioning that the validation that's done for Let's Encrypt is using HTTP validation, which requires you to have a server answering on both port 80 and port 443. You could configure LXD itself to listen on HTTPS port 443, but LXD does not do unencrypted listeners like pure HTTP. So you will still need to run Proxy, Nginx, or something else to just listen on HTTP and simply do an HTTPS redirection for any traffic that's arriving there. Our documentation has some examples around Proxy, which I'll try to use in the demo to make this work. All right. So let's switch over to terminal. So just checking the chat, all fine, cool. All right. So terminal here. And I should have LXD 5.7 now. Just see. I had to spend quite a bit of time to get the video encoding working for the stream, so I didn't have time to prepare the actual demo quite as much as usual. So let's see. Yep, 157. All good. So just run through LXD init to make sure we've got everything set up. There we go. Cool. And with that done, now let's see if my domain actually works. So it's supposed to be demo. Let's go on. Yes, cool. Okay, so the DNS record does exist, which hopefully means we can use it to encrypt on this thing. So I guess what we could look at is a fingerprint. So it's the current certificate fingerprint. And now if we set ACME domain would be demo. Well, actually, let's do things properly. So first thing we need to do is enable the HTTPS listener. So let's bind it on 8443. This means that now my machine, if I do this is responding. Okay. Next up, we need to install Proxy. Okay. And I'm gonna go grab the example configuration from our documentation. Just a moment. It actually shows how to do load balancing as well, which we don't need to do here, but the rest should apply. Okay. So if I go Proxy config, let's wipe it and put our config in place. And we just want to forward everything to localhost. Okay. It's not node 1 or anything, it's just LXD. Okay. All right. So let's just go through the config. So that sets up basic Proxy as a daemon with TLS 1.2. It listens, default settings for TCP. It will then have backends for both. Those are just doing plain redirects if we want. Then front ends will listen on HTTP and on HTTPS. For HTTPS, we're doing a domain snooping, so we need to change the domain name here to say that if we hit stemwascular.org, it should do SSL, it should jump to LXD nodes as the backend, and then LXD nodes does TCP back to localhost node on port 8443. Let me try now to restart the proxy. Okay. And if I try from my laptop here, so demo on 80, that works. On 443, that works too. Cool. So if I do this, forbidden match rules. Okay, that is not what we want to see. Let's see what's going on here. TCP. Oh, all right. Actually, that's correct. I just forgot to change the domain here too. So the fallback is to do forbidden for any other domains. So let's just do this. Then restart the proxy. Okay, there we go. So now we can see that when we access this one, let me do it before. This one gets bounced to demo. And now if I access the same thing or HTTPS, okay, it's complaining about the certificate, which is kind of the point. And if we ignore the certificate, then we're clearly talking to LXD, not an authenticated LXD. So there's actually, like, you can't access instances, for example. This is gonna fail, not authorized. Okay, so that's all good. We're talking to HTTP talks to LXD. So now that that's all done, let's go back on the server and then do config set. Domain is demo. Actually, let me get the fingerprint again first. Domain is demo and accept TOS true. Might as well have it notify me as well. That was it. Let's see. Oh, agree to us. Never mind. Okay, so let's do agree. Okay. That should give everything that LXD needs to go and handle the certificate. Okay. Let's see. Okay, well, that was quick. We can see the fingerprint has now changed. And let's try again from my laptop here. So this time I'm not gonna say that I want to ignore HTTPS error. All right, so now I'm doing it over HTTPS, and we can see that we are dealing with a valid certificate that was admitted by Let's Encrypt. So there we go. So that's that new feature. It really makes it very easy to run public LXD servers somewhere. There's a few extra things. If you're in a cluster, not every single machine is gonna go and do that on its own. Instead, the cluster leader is gonna do the certificate renewal and will then spread it to all of the other servers internally. So that will avoid spamming the Let's Encrypt API effectively. The other thing that's worth mentioning is that this will auto-renew. So the valid period for Let's Encrypt is usually 3 months. I believe we do it at about a month, and the certificate will automatically get reissued and redeployed by LXD. Cool. So that's that one. Now, next feature on the list, sorry, it's a bit harder than usual, I don't have multiple screens to look at, is the Cloud-init validation. So let's just launch ourselves a container that supports Cloud-init. Okay. And then we'll just go and set some config. So just Cloud-init.user data, blah. That is valid because this is not a cloud config type in Cloud-init. If you go look here, okay. There are multiple different types of Cloud-init metadata. The most common one is the cloud config, which is YAML, but that's not the only one. So LXD effectively checks that cloud config is present, and if it is, then it will go and validate YAML. This should not be valid YAML. and this is indeed failing now, saying that it can't parse it. LXD, as I said, does not currently validate that things are actually supported by Cloud-init. So presumably, while this is valid YAML, Cloud-init probably won't like that, but that does work. So that's effectively what we have in place. The exact same validation is happening on vendor data, as well as on network config. Network config doesn't need a header, it's directly YAML. So if I do this, that should clear. And if I do something like that, that should not. There we go. Cool. So that's just a nice convenience for those config keys that expect YAML. We're now validating that they are indeed YAML. As I said, we expect to have more validation coming in to validate more of the inside of the data. We're just waiting for those projects to have like a robust validator we can use. Alrighty. Next one is internal metrics. So if we go look at our metrics API, query 1.0 metrics. We see a lot of stuff. The bulk of it is gonna be around the container, and actually just do some wrapping on there. So let's pick all the keys. Okay, and then let's ignore anything that's for name U1. Okay. Those are the new keys now, so we can see that we currently have 0 background operations. Oops. There's one warning currently, so if I do warning list. Okay, so there's a warning. Can acknowledge it. Okay, you can see the uptime here. It's been about 10 minutes. Currently, 32 go routine is running. And then all of the memory allocation metrics here that would be most useful to graph, probably not so useful to read directly. And that's the new metrics feature. Now, next one is the cluster join token expiry. For that, I would need to actually turn this thing into a cluster first. So I just need to tweak a few things. See config set, so core HTTPS address. No, I want that to be a specific address. That is actually I can write on 45.45.142.43. Okay, and then cluster enable. Okay, so now this is a single node cluster. There we go. And normally we would do add and then add. Let's just do that. Yeah, that should be alright. What's complaining about exactly? Okay. Alright, so now we've got the token. And here we can see that it issued a cluster join token. You can see it here. But it also has an expires at field that gives us its expiry here. So in this case, we've got 3 hours to consume that token effectively. Checking the other commands we have here. And always, you can always go as well and manually revoke a token prior to that. But, yeah, I think. Cool. So yeah, this lets you see all of the expiries, see what's going on. At the API level, I believe there's also a way to directly set the expiry that we want when issuing a token. This is not currently exposed to the CLI, but that's something that that you can do. Alright. And the last one we have is the proxy device hot plugging to VM. That's not really something I can easily show here because you're gonna need to have an address and NAT it and all that stuff. Actually wondering, I might be able to do it. You know what, we've got a few minutes, let's try. So first thing first, I need an Ubuntu 2004 VM, so do that. I've not used proxy devices very much, so I need to load the documentation for them. On this side here. Try and get that done correctly. Okay. this will be that example. Okay, so that's the example from the documentation. So just need to change things a bit. So I'll do that v1, call it foo, proxy. So in this case, listen would be the host IP, 243, I think, 21234, and bind would be host, NAT would be true, and connect would be the instance IP, which I have no idea. Actually, yes, it's more complicated as TCP. Something else, I think TCP, so this one would be actually list and the IP of the instance. There we go. Instance IP for v1 and 244.113.247. Okay, must be one of these. Right. We do need to use the static IP address for that. So stop the instance. Config device override v1. It's network device, and we do network address 244.113.242. Then start it back up. And this time when it does the HTTP, it should get that specific lease, at which point it's safe to do NAT rules on it. Just takes a little while for it to actually start up. There we go. Picked up the address we want. And do the rule here. Cool. And now if I go inside the instance and I listen on port 80 here. And from my laptop, I access 4.8.243 on 1234. I'm connected and it works. So yeah, we can do this hot plug now. That's really quite nice. Again, proxy devices with VMs are a lot less featureful than they are with containers. Because with containers, we can do things like do cross protocol or completely different addresses, all that kind of stuff. Whereas for virtual machines, it's just a NAT rule we generate. So it requires the VM to use your host as its default gateway. So this cannot be used if you're using SIOV, MAC VLAN, or that kind of stuff. And it also needs so it is not well, yeah, and it needs the same protocol, the same address family, all that kind of stuff. You can't proxy between IPv6 and IPv4. You can't proxy between UDP and TCP or any of that kind of stuff. It's not impossible for us to do it in theory through the agent with a very complicated internal protocol. We just haven't seen a strong enough demand yet to really justify the engineering time to make a full-on proxy device working with a VM yet. Those tend to be a lot more useful with containers because we need to do things like graphical pass-through, SAMCAT pass-through, that kind of stuff, which all uses those kind of devices. For VMs, there's less of a need for that. But we'll say it's not impossible. We'll eventually add that. Okay, so that was it for your look at LXD 5.7. I'm just going to be switching back to the announcement here. There we go. So again, LXD 5.7 has been released yesterday. Announcement came out today. The snap package is available in latest candidates. That's what I was using for the demo. Additionally, you're gonna find it already available on Homebrew and on Chocolatey for Windows and macOS. And it will start rolling out through the stable snap channel next week. It takes about 72 hours for the entire phase rollouts to happen. So probably by Wednesday, most people should have it. Other distros have their own release cadence, update cadence for our packages. So not sure when LXD 5.7 will reach those. If you have any questions around this release, best is really the community forum, but you can also leave those comments in the YouTube comments if you prefer. And yeah, let us know how that works for you. Hopefully, at least the Let's Encrypt feature is going to be quite useful to a bunch of you folks. And I'll see you in the next video. Thanks for watching, and bye. I found my window to actually shut up the stream. All right.